Hello. So my project for the tracking was SAM-MD. So I combined FastSAM with a PyMDNet. So FastSAM is segment anything model from Meta. This was a attempt to improve that, make it a little bit quicker. And then the PyMDNet was a online tracker. So the MDNet was the VOT 2015 winner. So it's a bit dated, but it's still quite good. The MD is multi-domain discriminatively trained convolutional neural network. It's a new binary classifier layer is created for each new target in the online trained data from confident detections. So what happened was they trained their net on many different types of videos. And with each video, they added, in each new target, they added a domain specific layer. And that domain specific layer is trained online, whereas the feature extractors are trained offline from many different visual object tracking data sets. So the method that this uses is first it detects whether something is foreground or background. So that's giving potential bounding boxes or regions of interest. Then it goes through the multi-domain classification and bounding box. That was what was trained on the many different videos. Then it goes to the domain-specific bounding box, and this is trained online. So when you first start up the program, you give it the bounding box of the first instance. So if you look down at the right here, you'll see they gave it a particular horse, and it trains itself to identify that horse from that frame. Then it goes and gets the next frame, and it trains again to identify the same horse. And it does that over time until it has a very highly trained domain-specific detector, as well as this multiple domain detector. It does long-term and short-term updates. So the long-term update makes sure that the thing it's tracking is the original item, and this happens periodically. The short-term tracker is what happens when the the bounding box that's been tracking is suddenly detected as background instead of foreground. And when this happens, it reassesses and makes sure that it was not the foreground background detector, that there's actually something wrong. And then it looks through the image again and tries to refine that original object. So what are the pros and cons of this method? So it's effective. It's able to track the target through full occlusions, through large scale change. It can identify when it's tracking the wrong target. So if it switches over, tracks the person in the orange shirt instead of the red, the long-term adjustment will realize it's tracking the wrong person, and then it'll switch over to back to the red person. The online training definitely helps. It fits on my GPU. I've got an 8 GB RTX 3060 Ti. So some of these larger transformer models wouldn't fit on my GPU and wouldn't really be effective for me. There was great documentation. It was very simple to implement. I made it a few small changes to make it work with AV files instead of a list of JPEGs, but that was pretty simple. The cons is it's not really state of the art. It's a 2015 winner, but that was a long time ago, and some of these transformer models are better, but do take more GPU that I don't have. It does struggle with rapidly changing scale. So in this one, it worked fine, but as you'll see soon, if there's a rapid change, the bounding box stays about the same. Uh, and it could be overconfident. It can switch to a wrong person and then not realize it in the short-term detector. And then you have to wait for the long-term detector to come in. So then we're going to switch over to FastSAM. So now that I have that bounding box, I'm going over to FastSAM. And FastSAM is based on Meta's segment anything model. So this was a model that came out of Meta. They used a large transformer model, and it could take anything from a bounding box to a text to a a point and then give you your segmentation masks. And the issue with that is the transformer model was incredibly slow. So FastSam came through and they basically just used YOLO V8 with some pre-processing and some post-processing to do just as effectively as Sam did, but 50 times faster using just CNNs, no transformer. So you see this massive game. Now, this was with the RTX 3090. I've got the 3060 Ti. So I didn't see the same massive 40 milliseconds per image. I was getting probably about 500 milliseconds per image, which isn't great, but it worked well enough. The the model CNN backbone to fully connected layer, then it goes into different proposal networks. It detects, does a mask, and then it does the post processing here. So from the YOLO V8, you would get this kind of segmentation where it pretty much segments everything. And then from your prompt, it'll select what you want. So it's kind of cut off here. But if you look, say you gave the prompt the black dog, it'll select the black dog. If you put a box around the black dog, again, selects the black dog. And this is significantly faster than SAM while having still good recall. Again, does not use a transformer, does use bounding box region of interest. It goes through the the YOLO V8 segmentation and then tries to pick which of these segmentations were you talking about. And if it's a bad segmentation, say the knife was split into multiple pieces and you gave it a bounding box around the knife, it could connect all those segments together into one segment. So that's really useful for our situation. And it's really effective because the bounding box, it's not just selecting what's inside the bounding box, it's using that to choose what segment from the YOLO V8 should I use. So here you can see the bounding box from the MDNet was not particularly great, but it was able to understand it was talking about this person. So what are the pros? The pros is it's faster than SAM, and it still has that out of bounding box region of interest. It utilizes YOLO V8, which is a state-of-the-art great network. And it does the pre-processing and post-processing of that YOLO V8 for you. The cons is that it's slow at about 500 milliseconds per image on my machine, which isn't great. It doesn't do well with camera blur because it's trying to identify a person. If it can't identify a person, it can identify the next image that it sees. So here, maybe it didn't understand that this was a person due to image blur and occlusion. So the next thing it saw was this post. It said, I understand post is the closest thing to this bounding box. I'm going to highlight that post. So in that case, it can be worse. But if you were using this for something you really cared that you were only tracking a person and you were able to see that this was labeled as post, you could just ignore it. And it can select the wrong person if it's a bad return. So then here's my video. We'll go through this and I'll kind of talk about it as it goes. So one good thing is as the bounding box is bad, the SAM is able to select outside that bounding box. So I was really happy about this. As you can see, kind of bouncing around in this section, but still doing pretty well. It's able to, the tracker does a good job. The bounding box isn't great, but it does track the person in red, which is what we can hope for. Again, kind of picking up signs in other people as we run by them. But it did a good job not getting that purple guy. And then into the congestion, still doing well. That was a really large occlusion right there. Select correctly, got through the occlusion. And when you go frame by frame, you can see these ones where it like crazily grabs the track. There's incredible motion blur on that frame. And this, you can kind of see that the MDNet was tracking that guy in the orange. Then you got that long-term update, jump back to red. So that's what we love to see. And an offline trainer would have a significantly more difficulty in making that transition. And you can kind of see that it gets better throughout the video, which is what we'd expect, because I didn't train that. It started training as soon as the video started. It's not like I ran this a few times. So that's my video. I'm pretty happy with it. If I was going to redo it, there's a few changes I would make. Maybe I would go through the fast SAM and see if I can remove anything that I'm not absolutely needed, see if I can speed it up a little bit. I would go through the Pi MDNet and I would go in, find the attention and find the highest point of attention and use that as a point selector as well as the bounding box, so that in some of the more confusing cases, maybe you have a bounding box and a point for the fast SAM to use, and that should be a little bit better at grabbing that red person. But other than that, I'm happy with the results, and I think that it was a good method of combining two different systems, neither of them perfect, but together they complement each other. So thank you.